Kiran Sinha ma'am is here, and today we are going to talk about language of chemistry. So, first going into the chapter, I would like to explain why we need to learn language of chemistry when we are talking about the subject chemistry. Chemistry deals with the study of large number of materials around us, and due to interaction between the material and the environment, so many changes takes place around us. Many of the changes are permanent and chemical changes can be represented in the form of chemical equation. To write the equation, we need to write the symbolic form of element and compound. That's why we need to learn language of chemistry. So, let us start with the chapter. In this chapter, in language of chemistry, in this chapter we are going to talk about the abbreviation that is used to represent name of element and compound. We will learn to write chemical reactions in the form of equations, to write symbol of the elements, formula of the chemical compounds, how to write balance equation to represent the chemical reactions. So, we will talk about one by one. So, let us come to language of chemistry का first part, that is symbol is short form of an element and it is first used by Berzelius. It is the Sweden scientist and he used first time alphabetical letter to represent the name of element is called symbol. So, what is the significance of symbol? What information do we get from the symbol? So, symbol provide us two type of the information. Number one, qualitative. Qualitative means it represents the name of element. As for example, if we are writing C, C means name of the element, that is carbon. It is qualitative information that we are getting from the symbol. If we are writing Na, Na represents name of sodium. So, if somebody is writing H, O, N, C, F, I, in the English class, it is only one alphabet. But in the language of chemistry, H represents hydrogen, O represents oxygen, N represents nitrogen. So, this is the beauty of language of chemistry. In the short form, we can write the name of the element. Next, quantitative information. Quantitative related with quantity. How much? So, symbol represents one atom. If we are writing C, C represents one atom of carbon. If we are writing H, it represents one atom of hydrogen. If we are writing O, it represents one atom of oxygen. If we are writing Na, it represents one atom of sodium. So, one atom, it represents quantity. How much? It represents, symbol represents one atom. And it also represents the mass, atomic mass. So, symbol give the mass of that element which is equal to atomic mass. Suppose we are writing C. So, what is the mass of C? The mass of the C is equal to its atomic mass, that is 12 AMU. Mass is always represented in AMU, atomic mass unit. Atomic mass unit means what? 1 by 12 part of C, 12 is called AMU. कार्बन जिसका मास 12 है, उसके 1/12वें हिस्से को हम लोग बोलते हैं एटॉमिक मास यूनिट. सो एक AMU से ये एटम कितना गुना भारी, हाउ मेनी टाइम्स दिस एटम इज heavier, then 1 AMU is give the mass of this element. So, mass of carbon is 12 AMU. Mass of sodium is 23 AMU. So, symbol give us two information. Qualitative information means its name. Quantitative information means its mass and how many atoms. So, one atom. Symbol always represent one atom. How to write symbol? So, name of the symbol is derived from different methods. Suppose in the first case, we can see in some of the cases, symbol is just derived from the first letter of its name. Common name, English name, Latin name, first letter of its name. As for example, hydrogen written by H, O for oxygen, N for nitrogen, C for carbon, F for fluorine, B for boron, S for sulfur, P for phosphorus, K for calcium, V for vanadium, I for iodine, U for uranium. Just first letter of their name is taken as symbol. In some of the cases, the symbol of element is derived from two letters of their name. As for example, chlorine, calcium, cobalt, copper, chromium. These all are starting with C. But C is already assigned to carbon. So we cannot give the symbol C for chlorine, calcium, cobalt, copper and chromium. So symbol of these elements are derived from two letters of their name. As for example, chlorine, Cl first and third letter, calcium first two letter Ca, cobalt first two letter Co, copper symbol is cuprum. The cuprum symbol is derived from its Latin name. In Latin, copper is called cuprum. So Cu. Chromium first and third letter Cr. Suppose B. These elements are starting with B. Beryllium, bismuth, bromine, barium. These all elements are starting with the same letter. But B is already assigned to boron. So beryllium first two letter Be, bismuth first two letter Bi, bromine first two letter Br, barium first two letter Ba. So symbol sometimes derived from the first letter of their name, sometimes first two letter or first and third letter, matlab two letters from their name. In some cases symbol is derived from their Latin name. Suppose sodium. सोडियम का सिंबल होता है Na because its symbol is derived from natrium, its Latin name. Potassium symbol is K because its symbol is derived from its Latin name Kalium. Iron, its symbol Fe derived from its Latin name Ferrum. Copper, its symbol is Cu which is derived from Cuprum, its Latin name. Gold, Latin name is aurum, so Au is its symbol. Tin, the symbol is Sn, first and fourth letter of its Latin name stannum. Silver, first and third letter, symbol is Az, first and third letter of its Latin name argentum. Lead, symbol is Pb, first and fifth letter of its Latin name plumbum. Mercury, first and sixth letter of its Latin name hydrargyrum. Antimony symbol is Sb which is derived from its Latin name stibium. So symbol can be derived from the first letter, symbol can be derived from its name of taking the two letter, symbol can be derived from its Latin name. Next come to valency. C means number of electron lost, gained or shared by an atom of an element to complete its octet. If an atom have valence electron less than 8, then every atom will need to complete octet in its outermost shell. So one present in outermost shell is called valence electron. So valency of an element depends upon valence electron. If valence electron 1, 2 or 3, then element will have tendency to lose electron. So their valency is +1, +2 or +3. If valence electron is 1, then valency is +1 because it will lose 1 electron. If valence electron is 2, its valency will be +2 because it will lose 2 electron. Electron is 4, it means it will share 4 electron with other atom. It means its valency ±4. Always share 4 electron with other atom. If valence electron is 5, 6 or 7, its valency will be -3, -2, -1 respectively. And if valence electron is 8, it means its octet is complete. Then it will neither lose electron nor gain electron. So valency of an element always gives the number of atom lost, gained or shared by atom to complete its octet. So valency directly related with valence electron. Valence electron minimum 1 or maximum 8. If valence electron 1, 2, 3, valency is positive and element have tendency to lose electron. So valency always equal to number of electron lost. So if one valence electron, valency is plus 1. If valence electron is 2, valency will plus 2 because it will lose 2 electron. If valence electron is 3, its valency will be plus 3 because it have tendency to lose 3 electron. If valence electron is 4, it neither lose 4 electron nor gain 4 electron. So it has to share 4 electron. So its valency is 4. If the valence electron is 5, 6 or 7, its valency will be minus 3, minus 2, minus 1 respectively because they have tendency to gain electron. Generally, hydrogen and metals have tendency to lose electron, so they are electropositive in nature and their valency plus 1, plus 2 or plus 3. Non-metals generally have tendency to gain electron and they are called electronegative and their valency may be minus 3, minus 2 or minus 1 because they have valence electron 5, 6 or 7. Noble gases have complete octet, so their valency is 0. They neither lose electron nor gain electron. Some elements show more than one valency in different compound. In that case, they are called variable valency. As for example, FeCl2, in this compound, valency of iron is 2. FeCl3, in this compound, iron have valency 3. So lower valency is suffix as, we will call it ferrous chloride, and higher valency 3. So higher valency have suffix ic, we will call it ferric chloride. So ferrous chloride, ferric chloride is named due to different valency of the iron in different compound. As for example, copper also show variable valency. In some of the compound its valency is 1. When copper have valency plus 1, it is named as cuprous oxide, cuprous chloride. And if copper has valency plus 2, then it is called cupric. So higher valency always suffix ic and lower valency always suffix as. Lead also have variable valency plus 2 and plus 4. So lower valency named as plumbous and higher valency named as plumbic. In radicals, actually radicals are atom or group of atom which have charge, positive charge or negative charge. So radicals are atom or group of atom which have charge and they behave like single unit in the chemical reaction. Radicals on the basis of charge, they are maybe positive charge or they are maybe negative charge. So positive charge radical is called electropositive radical and negative charge radical is called electronegative radical. Positive charge radicals are also called basic radicals. So ammonium, sodium, potassium, calcium, these all are basic radicals. Ions of metal is basic radical. Of ammonium is also basic radical. It is the single non-metallic positive radical which is basic radical. Electronegative radicals are called acidic radical. As for example, chloride, bromide, sulfate, nitrate, bicarbonate, bisulfate, these all are non-metallic atom with single or group of atom which carry charge. So these all are acidic radical because during the formation of salt, these comes from the acid. So these are called acidic radical. Chloride is the part of hydrochloric acid. Bromide is the part of hydrobromic acid. Sulfate is the part of sulfuric acid. Nitrate is the part of nitric acid. All comes from the acid, so they are called acidic radical. On the basis of composition, radicals may be simple or may be complex. When the radicals is made up of only one kind of atom or it is made up of single atom, then it is called simple radical. As for example, sodium ion, it is made up of only sodium atom. Potassium ion, chloride ion, bromide ion, it is made up of only one kind of atom. But radical is made up of group of atom, group of different atoms, and they carry charge and act as a single unit, then it is called complex radical. As for example, carbonate, CO3. It is made up of 1 atom of carbon and 3 atom of oxygen, and it carry -2 charge. So it is complex radical because it is carrying charge. So it is radical, and complex because it is made up of different kind of atoms. Sulfate ion, it is made up of 1 sulfur and 4 oxygen atom, and since it is carrying charge, so it is radical. Bicarbonate ion, made up of hydrogen, carbon and 3 atom of oxygen, and it carry -1 charge, so it is radical. So complex radical made up of 2 or more than 2 kind of atoms, and they behave like a single group in the chemical reaction. They may be positive, they may be negative. In the next video, we will talk about how to write the formula of chemical compound, and how to write balance equation. And if you like the video, please subscribe the channel and share it with your friends, so that you can get the notification of the new video on time.